see you in this certain number to be present for this presentation. What I'm about to tell you now is the presentation about the construction and materialization of the Twistbox Pavilion. The main idea and the main concept of the house came from the basic concept of the competition. For each element of the house to be produced in the native country that competitors are from, to assemble and test the object in the native country, then to reassemble it, pack it and transport it to Dubai, where it has to be assembled again during the 10-day period in which each element has to be set down. And that period of time, 10 days, actually consists not only structural composing of the object, but complete exterior and interior design, both greenery and furnishing. As the concept of the construction is concerned, we have decided to use the prefabricated wooden system that is actually easy to assemble, with the possibility of assembling and reassembling without any damages, or if there were any damages, that we keep them at a minimum, because the object itself is going to be assembled and reassembled at least twice during its lifetime. Dimensional optimization of the element is actually quite important, given that it's easily transferable, but in order to do so you have to take into consideration the maximum size of the container that is going to be transported with, or even the truck, depending on the system of transportation that we're going to use. The concept of the execution is actually pretty interesting, given that students are the ones who are going to execute an entire object. They have to be submitted to a professional training by the professionals and engaging the qualified and professional teamwork that are going to teach students how to actually operate with each element, how to install each element, how to develop an entire home and house and operate the mechanization themselves. Given that there is the use of mechanization, we have to use cranes there that are going to be used with each team, but the organizers are going to propose each time for each team, so that efficiency in using it is going to be okay, and the use is actually going to be paid per an hour, and that price is something that we do not know yet, so it's upcoming. These are the analysis of structural solutions, actually. These are varieties of student works from the very beginning of the designing phase until now that we have designed what you saw in the previous presentation by the professor. We began with the wooden truss construction that was actually primarily used for a concept of maximum glazing of the facade. Then we went with construction elements structural system, which didn't really show itself as useful and purposeful. Then we went to steel construction, but in the end we ended up with wooden prefabricated panel constructed system. This is the actual valorization of each structural system that we used, and you can see each solution has many options, and the one that actually won is the conifer timber construction with structural panel system. Why? Because, you know, trees, renewable source, you can play with it, you can do whatever you want with it, and in the end the impact on the environment is pretty low, almost there is none of it. But you can see that it's easy to transport, it's easy to prefabricate, it's easy to install. It weighs like minimum, and it has really good thermal solutions. As far as footing is concerned, we have 18 footing pads that are, and 18 footing pads and 6 floor panels that are lying onto it. Each of those panels actually have 24 centimeters of mineral insulation within it and 24 centimeter rib construction to support all the thermal components as needed. This is actually the plan of the floor plan, where you can see that it's made of rib construction, the previously mentioned rib structural panels, and you can see the various types of interior walls. The exterior facade walls are all 30 centimeters thick, but you have like variety of interior walls, which is actually consistent given that none of those actually have structural purpose. So we're on the solving many other solutions of these elements. This is the plan of the mezzanine that actually consists the sleeping area. We have used this opening as a communication. Where you can see on the southern side, we have the openings on each side of the mezzanine of the room in order to like keep communication with the gallery downstairs. But also we have an option of closing and opening those louvers, so you can play with intimacy of the private space. The roof construction is also made out of wooden prefabricated panels, also 24 centimeters thick, but we have an interesting solution of ventilating it, which can be seen on the longitudinal section. We have this airflow tunnel that actually helps this better insulating system and prevents heat overloads to the house. Also, it can be seen on the cross section here, where you have pretty dense rib construction of the roof, given that it has to support these rissoles that actually lay on the steel rails, both at the base and the roof top of the house. The facade is something that we went from the beginning. We wanted like fully glazed facade. Like every architect would like to have something that is, you know, fully transparent, that everyone can see what goes on inside. But given that we've performed quite an analysis of the traditional systems and their play, so to say, of the intimacy and privacy of the space, we've ended up with minimum as we could get glazing system on the facade, which is mostly on the southern side because it's a common area. It's something that doesn't really require much of the intimacy, but also it allows a lot of sunlight penetration into the house without any heating overloads, given that we have our rissolale system that actually prevents those. As the interior is concerned, we are going for oriented strand board and gypsum panels on the interior side, because we'd like to play with light wood, light-colored wood actually, and white paneling, which actually gives nice aesthetics to the house and the interior itself, because it gives that homey atmosphere that we want to achieve, and we hope we have achieved. We have a full decking of the house, which gives the warmth and the natural looks to the interior, and it can be seen on these renderings here. You have the living room, 2 renderings of the living room. You can see that it has a lot of used wood and white paneling there. It really looks pretty amazing, given that we didn't have this like 3 months ago. But you know, the sleeping area is really compact, because we didn't have much space upstairs, but we managed somehow to achieve the usability of the usage of the space. The bristles are made of, we have proposed an ethylene tetrafluoroethylene, but it may result in ending solution with polytetrafluoroethylene material that actually can help us achieve this height of the bristlet, because you know, with this kind of height, like 6 meters, you can have pretty much suffering with its own weight, its own load bearing. So we have to think of something that is, you know, existing and doesn't die fast. So we went with this solution, which is interesting because at the beginning solution we had almost 360 bristlets that were actually torted rectangles, and they were 25 centimeters thick. With the optimization, we came with a solution of 60 centimeters thick triangulated bristlets that actually give a better aesthetic and better conception of what we want to achieve than the previous solution. We have a student work here that actually showed how the process of choosing bristlets and system of bristlets went. These are some of the solutions that showed the dynamics of the bristlets, given that we want to achieve, once again, the play with sunlight, with sun penetration, with privacy of the house. So it has to be movable, it has to be dynamic, because our torted structure is dynamic per se. We have here the choice of materials, which is quite interesting, that I've mentioned before. You have this polytetrafluoroethylene material that is actually something you could find in, I think, O2 Dome in London. It has a limited lifetime, but you know, this house is supposed to live like 2 weeks during the competition period, so everything above that is marvelous. So that would be what we meant to show you, actually, in the light of construction materialization, and I hope you liked the presentation itself. Thank you for the attention.